Welcome back, Algebra 2 students, to another Regents review video. This is the June 2016 Algebra 2, my apologies, Algebra 2 Common Core. Algebra 2 Common Core exam for the June 2016 exam. These are going to be the solutions to Part 1, which are the multiple choice. We're doing questions 13 through 24 of this exam. So, before we begin, the same thing over and over and over again. Do not cheat off of this video. You should not be here if you're doing so. If you came here for some assistance, you've come to the right place. You want to check your answers, you come to the right place. If you want to see another way how to do a problem, you've come to the right place. But otherwise, you're not being ethical and you got to get out of here. Please. The Algebra 2 exam is a challenging Regents, and you need to know how to do the problems really well in order to do decent on this exam. Make sure that you hit that subscribe button down below. Consider becoming a patron on my Patreon page. I would greatly appreciate it. And make sure that you visit my website at www.nysmathregionsprep.com for more content in Algebra 2 and your future mathematical subjects such as calculus. Both of those links can be found in the description below. And I use the TI Inspire CX calculator for Algebra 2. You can find that link on my website as well, and it links you right to Amazon. Without further ado, let's jump right now to question number 13 of this exam, and we begin with not a challenging question, but a wordy question. Here we go. 13 says, the Ferris wheel at the landmark Navy Pier in Chicago takes 7 minutes to make one full rotation. The height h in feet above the ground of one of the 6-person cars can be modeled by, that function, okay, where t is the time in minutes. Using h of t for one full rotation, this car's minimum height in feet is what? Okay, there's a couple ways that you could do this, folks. First and foremost, you need to understand what this is telling you. This is the height function, and it's a sinusoidal curve. Sinusoidal just means that there's a sign, S-I-N, sin. There's a sign right there. So it's going to look something like a wavy type of function, okay? Not too bad. So there's a couple ways that you could do this. You could do it graphically on the graphing calculator, or you could understand what's going on here. I'm going to show you the understanding of what all of that stuff in the equation means, and I'm going to show you how to do it on a graph. So this, ladies and gentlemen, that you see right there, that 80, the plus 80, this represents a vertical shift of plus 80 units. So that means if you're starting at the origin, this goes 80 above the origin, okay? This 70 that you see right here, this represents the amplitude, okay? The amplitude is simply just you take the entire function and you find the midline of where that is, the midline up or the midline down. That is your amplitude. It's how high that sinusoidal curve goes from the midline. So basically what you're doing is to find the minimum height. The minimum height is you're doing the formula midline minus the amplitude, okay, to find your minimum height. So let me just show you what it may look like in like a little picture here, okay? And of course, this is not drawn. I promise you that this is not drawn to scale. This is just a basic sketch, okay? If I were to draw a sinusoidal curve, like maybe, I don't know, 80 above, it will look something like this, okay? Pretty good looking drawing. So this is 80, and the amplitude from the midline down is 70. So the amplitude is 70, and then the same thing up here. As I said, not drawn to scale, but this is 70 as well, okay? So the midline in this case is 80, okay? So you just take 80 minus the amplitude of 70, you get a value of 10, which is your answer. Your answer is choice 3. That is your minimum height. Now, what would you think your maximum height would be? Well, your maximum height would be your midline plus the amplitude, which would be 150. 150 is your maximum height. So that's how you do it if you know what each piece means in this equation. Now, what happens if you want to do it on the graphing calculator? I'm glad you asked. Go to your graphing calculator, click on Add a Graph, and what you're going to do is you're going to type in exactly what you see, except you're going to change the letter T to the letter X when you type it into the calculator. So we get 70 sine of control division 2 pi over 7 parenthesis x minus 1.75 parenthesis plus 80. So now you're probably not even going to see it. Yeah, you can't see it. So what I'm going to do is I'm going to do menu. I'm going to go to Windows Zoom, and I'm going to click on Zoom Fit. What it does is it actually fits the entire graph in for you. Oh, beautiful, beautiful. Graph fit. Nice. We want to find the minimum value. So these are your mins down here. These are all the same minimums. So just click on menu, analyze graph, click on minimum, and do any one of them. I'm just going to click this one over here. Now, as you can see, this is the point 710. Your minimum height is the 10. It's your y values, your vertical axis. That's the height. The x's down here, these are your minutes. We're looking for the height. In this case, it's 10. Your answer is choice 3. Okay? Not too bad of a question, just very wordy. Okay, this type of question, the expression 4x cubed plus 5x plus 10 divided by 2x plus 3 is equivalent to what? I highly recommend that you either know how to do synthetic division or polynomial division. I truly believe that synthetic division is significantly easier than polynomial division. Synthetic division, basically what you're doing is you're taking the coefficients of the numerator, you're writing them down, so 4, 0, 5, and 10. Oh, wait, where did I get that 0 from? We don't have an x squared term. We have an x cubed term and x to the 0 power. We don't have an x squared, so what you need to do is you need to put in a placeholder of 0 for the x squared. Okay? And your teachers usually told you, all right, guys, draw a little window or a box, draw your last line over here, and draw an equals bar down here. Bring down that 4, and then start your synthetic division process. But what goes in this box? Well, what we need to do is we need to take the denominator, and we need to set it equal to 0 and solve for x. So we get 2x equals negative 3. Just move that 3 to the right-hand side and divide by 2. We get x is equal to negative 3 halves. So your job is to take that negative 3 halves and plug it into your little box over here. So now let's go ahead and perform synthetic division. So all we do is we take this number and we're going to multiply it to this number. Okay? Whatever that result is, we put it over here. Okay? Let's do it. So 4 times negative 3 halves gives you a negative 6. That negative 6 goes there. Okay? Now what your job is we're going to add these numbers. 0 plus negative 6 is negative 6. Okay. Now what we're going to do is we're just going to repeat the process. Take negative 6 and multiply it to the negative 3 halves. Okay? Negative 6 times negative 3 halves gives you a positive 9. Okay? Now we're going to add these two numbers. 9 plus 5 is 14. Bring down that 14 over here. Now once we get that 14, we're going to do the same thing as we did before. I'm going to take that 14 and I'm going to multiply it to that negative 3 halves. 14 times negative 3 halves gives you a negative 21. Now you're going to add these and you get negative 11. Now, ladies and gentlemen, let me explain to you what I just did. Okay, so we have a 4, we have a negative 6, we have a 14, and we have a negative 11. Okay, so what I just found here is I just synthetically divided this polynomial. What do I get? Well, these are now the coefficients of my new polynomial. Okay? And this 11 over here in its lonesome corner, this is your remainder. So there's a remainder of negative 11. So remember when you perform synthetic division, the original polynomial drops by 1 degree. So the highest degree is 3. So now the highest degree when you synthetically divide is an x squared term, or a degree of 2. So what we're going to do is we're going to take these coefficients and we're going to slap on the descending powers, okay? So we get 4x squared minus 6x plus 14. Now, what do we do with that remainder? Well, we add on the remainder over the divisor, which is 2x plus 3. Ladies and gentlemen, that is called the division algorithm. The division algorithm is you take, this is called your quotient, okay? This is called your quotient. And this is the remainder. And this is the divisor. This is called the division algorithm. And if you downloaded my Facts You Must Know codes for the Algebra 2 Regents off of my website, this is right on the first page, division algorithm. You need to know how to do it because it is obviously a Regents question. Why would I put it on there for your, what, for your health? No. And your answer is choice 2. Now, wait a minute, Trevor. I don't know where the heck you just got that from because you get a whole bunch of different numbers down here. You got 4, -6, and 14. Now you got 2, -3, and 7. Well, let me tell you what they just did. They decided to just divide by 2 or take out a factor of 2. Your answer is choice 2 anyway. Because what they decided, all right, no problem, just take out a factor of 2. And now if you want to just check it, just distribute it in, you get back to the original. So that's all they did. And pretty simple stuff. Your answer is choice 2. Make sure that you know how to synthetically divide. Number 15. Which function represents exponential decay? Which function represents exponential decay? So decay meaning going down. So exponential decay looks something like this. Okay? It's going down very, very quickly. So you're really so there's a couple ways that you could do this. Either you could graph it, which I highly recommend, or you basically look at the exponents and the numbers that they are associated with. So everything here is positive. That is a 2. That's not a fraction. This is exponential growth. This is greater than 2. Exponent's positive. This is exponential growth. Oh, be careful here. This is a fraction raised to a negative exponent. This is actually growth. And this over here, this is really y is equal to 1/5 raised to the positive t. So what it's doing here, folks, is you move that t down to the denominator. So this is really y equals 1/5t, which you should know your exponent rules. This is the same thing as 1/5 to the t power, because that's just a 1. So this is actually exponential decay. Your answer is choice 4. Okay? Just for the sole fact that 1/5 is less than the number 1, that's why it's exponential decay. This one is growth because that negative t pushes it down to the denominator, and you actually get a number that's greater than the number 1. So let's just say you did not know any of that stuff. Trevor, how do I save myself? Well, you can go ahead and graph it. So I'm going to graph everything for you. I'm going to graph everything. I'm going to graph 2 raised to the 0.3x. Get that. That's growth. 1.2. Next one, 1.2. Raised to the 3x. That's growth. We got that. 1/2 raised to the negative x power. That's growth again. We got that. And we get 5 to the negative x. We get decay. Your answer is choice 4. Pretty simple stuff. Just graph it. Number 16, given f inverse of x equals -3/4 x plus 2, which equation represents f of x? Okay, this one's not that bad. Just a little tricky just because they give you the inverse function. And remember what the inverse is. The inverse is always reflective over the line y equals x, or reflexive over the line. That's almost offer. Reflexive over the line y equals x. So you have 2 ways. I'm going to show you both ways again. I'm going to show you how to do it algebraically. Then I'm going to show you how to do it graphically. Here's the algebraic way first. To find the inverse, like if they give you f of x, the original f of x, to find the inverse, you switch the x and y and you solve for y. You switch the x and y and you solve for y. Well, how do you get from the inverse back to the original function? Switch the x and y, solve for y. Same thing, going in reverse. It's the same thing, same steps. Pretty simple stuff. Not a big deal. So here are your steps. I always like to write out steps. Always do. Step 1. To solve for the original function given the inverse. Switch the x and y. Okay? Then step 2, solve for y. And you have your original function back. Let's do it. So what I'm going to do here, folks, is I'm actually going to replace f inverse of x with the letter y, just because we like seeing y a little bit better than f inverse of x. Okay, now I don't want you to get confused. I'm going to put this in a different color just so you guys don't get confused. This is really y inverse. All I did is I just replaced f inverse of x with y inverse. We did not just solve for y. We did not just solve for y or f of x. So your goal is to solve for f of x, which is really just solving for the original equation y. So here we go. First step, switch the x and the y. So we get x equals negative 3/4 y plus 2. Okay? We're almost there. So now we're going to solve for y. Subtract the 2 on both sides. We get x minus 2 equals negative 3/4 y. Now to solve for y, we're going to multiply by the reciprocal of negative 4/3. Okay? Those cancel. And we get the original function, y, which is, again, f of x, is equal to negative 4/3 x plus 8/3. Ladies and gentlemen, this is f of x. Negative 4/3 x plus 8/3. Is that answer there? Your answer is choice 2. That is how you do it algebraically. Okay, that's how you do it algebraically. Just those steps. Switch the x and y, solve for y, and you get choice 2 as your answer. Now let's just say you did not know how to do that, and I just told you that all inverses are reflected over the line y equals x. So what I'm going to do for you is I'm going to go to my graphing calculator, and I'm going to graph for you negative 3/4 x plus 2. That is the inverse function. Then I'm going to graph y equals x. Okay? Now I'm going to graph my answer and see if it works. I'm going to go ahead and graph my answer. Negative 4/3 x plus 8/3. Okay, look at what just happened here. You see how the line y equals x passes directly through the point of intersection between these two lines, and they are perfect mirror images of each other over the line y equals x. That's how you know you got this answer correct. Okay, so your answer for that one is choice 2. Moving on to number 17. Okay, this one, challenging. This is a really in-depth trig question. Here we go. A circle centered at the origin has a radius of 10 units. Stop right there. Draw yourself a figure. And since you took the geometry, Regents, or you passed geometry, you should know how to graph a circle centered at the origin. You just graph a circle centered at the origin, meaning it's in the center, and you just draw it. That's it. Okay, so we have this circle. Perfect. Now, it says here it has a radius of 10 units. I'm going to leave that off for a second. The terminal side of an angle theta intercepts the circle in quadrant 2 at point C. The y-coordinate of point C is 8. What is the value of cosine theta? Some of you are like, what is he talking about? So here we go. They tell you that the circle intercepts a point somewhere in quadrant 2, and it lies on the circle, and they call it point C. So this dot, I'm going to call this dot point C. And they tell you that the y-coordinate is 8. So we don't know what the x value is. I'm going to put a question mark there, and I'm going to put the value of 8 for the y value. Now, a couple things that you need to understand. When they tell you that the y value is 8, okay? When they tell you that the y value is 8, that means that your vertical height has to be 8 units, okay? So this here is the number 8. Okay, that is your y value. If you start from the origin and go up by 8 units, that's your point right there. Okay, and that's just basic, really, Algebra 1 graphing stuff. Okay, Now, they tell you that the radius is 10. Now, most of you are probably prone to say, all right, Trev, if the radius is 10, boom, that's your radius of 10. No questions asked. And you might say, all right, Trev, this is a radius of 10. No questions asked. The problem is, folks, is that you need to draw yourselves a right triangle. You cannot get this answer correct if you do not draw yourself a right triangle. That is also a radius of 10. By definition, remember from geometry, a radius is drawn from the center of the circle to the to the circle where it intersects the circle. In this case, it's drawn from the center and it intersects the circle at point C. Pretty simple stuff. And that tells you that it's a radius of 10. Now, look at this. Now it's easy peasy. Easy peasy lemon squeezy. Look at this. We need to find the x value. Remember that the x is the horizontal distance on the graph. So this is your x-axis and this is your y-axis. We're trying to find x. Easy. How do we do it? Well, this is a right triangle. What could you use to solve for the third side of a right triangle given two sides? The Pythagorean Theorem. So we need to use a squared plus b squared equals c squared. The 10 is your hypotenuse. Don't forget from geometry, the 10 is your hypotenuse. It's across from the right angle, and these are your legs. So we get x squared plus 8 squared equals 10 squared. X squared plus 64 equals 100. Subtract the 64 on both sides. We get x squared equals 36. Take the square root. Then we get x is equal to plus or minus 6. Now, the reason why I indicated plus or minus 6 is for this reason, folks. This value of x is actually negative 6. Why is it negative 6 and not positive 6? Trevor, I thought that lengths are always positive. Let me be more specific. This is the x-axis. In this direction, it's positive x values. In this direction, it's negative x values. So your answer has to be a negative 6 value. I don't care about distance. I only care about trigonometry. We are not using, we're not finding the length, width, height, volume, area. We're not finding anything that's geometric. Okay, geometric means everything has to be positive. We're using trigonometry. A side could be negative. So don't be confused that, hey, I got a negative. It has to be positive. No. In trigonometry, things can be negative. Just keep that in the back of your brain. I don't want you to get confused with that. Okay? I'm going to move. Oops, I don't want that stuff. I'm going to move this off to the side for a second. My head will be blocking it. I apologize. Okay, and what we're going to do is we're going to find cosine theta. Well, where is theta? I didn't even tell you where theta was. Well, theta is right over here. Theta is right there. Just a Greek letter theta. And they want you to find the cosine of theta. Well, this is back from geometry right here. SOHCAHTOA. All right? SOHCAHTOA. This course, ladies and gentlemen, Algebra 2 is really a combination of Algebra 1, geometry, and more advanced material in Algebra 2. So it really just ties everything together from what you've been doing. So we're using CAH, so cosine. Okay? We're using cosine. So cosine of theta is equal to the adjacent side. Remember, adjacent means next to. And your hypotenuse is 10. So to find the value of cosine, we just found it. Cosine theta. Cosine theta is negative 6/10, which could also be reduced to negative 3/5. Ladies and gentlemen, that is your answer. Your answer is choice 1 for that question. Honestly, not a bad question. Could have been a lot worse, but just got to know your trick stuff. Pretty simple stuff. Number 18. Which statement about the graph of c of x equals log base 6 of x is false? So, immediately, you should be thinking to yourself, Trevor, we got to graph this puppy. We got to graph it. Graph it on your calculator. Let's do it. Go to graph. Your log button, the log button on this calculator is found in two spots. Either you could do control 10 raised to the x and you get log, or you could do the button next to the book and you get log over here. Okay? I usually like to go in that button. Okay, so log base 6 of x. Graph it. Okay, so we get this function. I want you to understand that I know it gets cut off here, but it should be going down forever. Log functions go down forever because it has, in this case, it has a vertical asymptote of x equals 0. So let's go ahead through these answers and let's see what we're talking about. Which statement about the graph is false? I'm actually going to take a picture. Oh, I need to silence my computer because your ears are going to blow off. So it's going to get a little dark here for a second. All right, I'm going to copy this. I'm going to put it on the page so I could draw it. Okay, so we got this. And let's talk about it. Okay, so we got this. Here we go. The asymptote has the equation y equals 0. Okay, so y equals 0 is right here. Okay, that's y equals 0. Is that an asymptote? No. An asymptote means that the graph is slowly approaching that number, or it is leveling off in relation to that asymptote. Asymptote doesn't mean that you're just approaching it necessarily, because you'll see in calculus that an asymptote could like jump and then smooth out. So, but that's false. That is a false statement. What it should really say, folks, is it should say that the asymptote has the equation x equals 0. Remember what I just said before? This has a vertical asymptote of x equals 0 because it goes down forever, but it never crosses that x-axis, because the minute a log becomes 0 or negative, the log is non-existent. A log has to be positive. The graph has no y-intercept. That's true. That is absolutely true. The graph has no y-intercept. Never touches the y-intercept. Sorry, I meant to say y-intercept before, not not x-axis. I meant to say y-axis. It can never indicate. It cannot cross to the left of the y-axis. The domain is a set of positive reals. Yeah, positive reals meaning in this direction. Yep, positive reals. That direction. All over here. Positive reals. Good. We're good. So that's true. That's true. The range is a set of all real numbers. Absolutely. You're going up and down forever. You're going in this direction, and you're going in this direction. That is absolutely true. So your answer is choice 1. Moving on to number 19. Okay. Remember how I said in Algebra 1 that you should remember completing the square? And I said in geometry, you should remember completing the square. Here it is. Trevor's right. Completing the square. What do you know? The equation 4x squared minus 24x plus 4y squared plus 72y equals 76 is equivalent to what? Now it's just a much more complicated. It's no longer geometry here. Now we got a whole bunch of stuff. So we got 4s, 24s, 4, 72, 76. What do we do? What do we got to do? So what we need to do is we got to say, hey, this has to be a 1. This has to be a 1. So, but they're both 4s. What we could do is we could actually factor out a 4. They were nice to you. Every number here is factorable by 4. Or 4 goes into all of these numbers. Each of these numbers is divisible by 4. So take out a 4 out of all of it. All of it. You're taking out a 4 of all of it. You're left with x squared minus 6x plus y squared plus 18y equals 19. Okay? Now, folks, we can complete the square. Now we got this. We got it. We can complete the square in here. We know how to complete the square from this because we paid attention in geometry last year. I hope. So, we get 4. I'm going to put a bracket here because it's going to get very messy. So, I'm going to use different colors here. We get x squared minus 6x plus something plus y squared plus 18y plus something equals 19 plus something plus something. Remember, what you do to one side of the equation, you must do to the other side of the equation. So let's go ahead and find out what those blank spaces are. Don't forget, I should say, that the formula to get these boxes or lines is b divided by 2 squared. Take half the middle and you square it. So half of negative 6 is negative 3. Negative 3 squared is 9. Put a 9 over here. Put a 9 over here. And half of 18 is 9. 9 squared is 81. 81, 81. So now what we're going to do is we're going to factor this. What adds to negative 6? What multiplies to give you 9? What adds to 18 and multiplies to give you 81? So let's simplify this a little bit further here. So we get 4, bracket, in parentheses. Remember, when you complete the square, you get 2 of the same term. I'm going to speed it up a little bit. The factors of x squared minus 6x plus 9 is x minus 3, x minus 3. That's just going to be x minus 3 squared. Plus, these factors are y plus 9, y plus 9. That's just y plus 9 squared. And that gives you, when you add up these numbers, you get 109. Okay, we're almost done. Now, all we got to do is we got to take this 4, because if you look at your answer choices, it doesn't show that. What they decided to do is they just distributed back the 4 to all of these. So your answer is 4 times x minus 3 squared plus 4 times y plus 9 squared is equal to 436. Your answer is choice 4 for that question. That was hard, in my opinion. Okay, number 20. This is like, this is not a stupid question, but it's like you gotta know what you're talking about. So 20 says, there was a study done on oxygen consumption of snails as a function of pH. Okay, and the result was a degree 4 polynomial function whose graph is shown below. By the way, folks, degree 4 literally means it's an even polynomial. It's an even polynomial. What it's telling you is that if it's degree 4, the highest degree in that polynomial is 4. Okay? So, which statement about this function is incorrect? All right. The degree of the polynomial is even. I just said it. The degree of the polynomial is even. It's degree 4. So that is true. Bye-bye. There is a positive leading coefficient. Positive leading coefficient. So, you need to know the end behavior of even polynomials. Okay. Some teachers might teach this differently. I really don't teach it differently. This is how you do it. This is how you do it. An even polynomial. All right, so degree 4, all you're really doing is you're adding some extra like crevice or like a hump, like 2 humps on the graph. Here's the thing. Even polynomials all have the same end behavior as long as they're an even polynomial and they have the same leading coefficient. Let me explain why. So all even polynomials can relate back to the quadratic. Let's make it easy on ourselves, okay? If you have a quadratic that has a positive leading coefficient, it's a happy face. Remember when we did quadratics back in Algebra 1? If it had a positive leading coefficient, it's a happy face. And if it is a negative leading coefficient, it's a sad face, right? Well, since a quadratic is an even polynomial, all even polynomials, no matter how big the even number is, all relates back to the end behavior of the quadratic. So if it's a positive leading coefficient, the end behavior is going up on the graph. If it's a negative leading coefficient, the arrows are pointing down on the graph. So if you're looking here, it says there's a positive leading coefficient. No, there's not. It's a negative leading coefficient. It's a sad face because, again, the arrows are pointing downwards. They're going in this direction down here. It stops up here. It doesn't go any higher. So it has to be a negative leading coefficient. That's why your answer is choice 2. But let's just say you didn't get that answer and you were confused about the other couple down here. So choices 3 and 4. Choice 3 says at 2 pH values, there's a relative maximum value. It says here that there is a relative maximum at 2 pH values. Well, where's that relative maximum? Your relative maximum is here and here at 2 pH values. Relative maximum means the highest point on the graph. And since it's relative, there's 2 of them, okay? Relative means that there might be 2 of the same value. An absolute maximum means that it's the highest point on the graph. These are both the same value at, what is it, like 0.07-ish, somewhere around there. It's not 0.08, but it's somewhere around there. Okay, so that is true. Then there are 2 intervals where the function is decreasing, absolutely, and it took a keen eye to see it. The two intervals where it's decreasing is here and here. So it's increasing here to here, but it's decreasing for the greens. So that's why both of those answers down there are true. Okay? So your answer for number 20 is going to be choice 2 for that question. All right, moving on to number 21. Last year, the total revenue for Homestyle, a national restaurant chain, increased 5.25% over the previous year. If this trend were to continue, which expression could the company's chief financial officer use to approximate their monthly percent increase in revenue? Let M represent the number of months. That's important because I see months, and if I go back here, it increased by 5.25% over the previous year. So you got to be thinking to yourself, hey, how many months are there in a year? Well, there's 12 months in a year. So what you got to do, first of all, is you need to take 5.25% and convert it to a decimal. To convert to a decimal, you move that decimal point 2 places back. Oops, that was a horrible arrow. 2 places back. Okay, so you get 0.0525. Okay, so now all you need to do is you need to take the percent, 0.0525, and raise it to the 1/12th power. What this does is it shows 1 over 12. What this does is it converts it to years. Okay, converts to years, because for every year there are 12 months in a year. So when you type this into your calculator, you get this number, 0.0047. Okay, so if you look back, it's increasing. So it has to be, so the inside the parentheses, it has to be 1 plus the rate. So it's 1.0047. Okay, so your answer in this case is going to be choice 3. Choice 1, they failed to convert this to the amount of years. You see how M represents months? No, they want it in years. Okay, so that can't work. This is the wrong conversion factor. This is 12 divided by M. That makes no sense. This is M divided by 12. That makes no sense because here's the thing. This would make sense if this number was 1.0525, but it's not. What they did is they tried to trick you. They converted it and then kept the 12 on. That's not how it works. You need to take this number, raise this number to that number, which you get 0.0047, add that 1 on, and then raise it to the M power. Your answer is choice 3. My opinion, that was a pretty hard question. Moving on to the last 3 of this exam. Sorry, the last 3 multiple choice of this video. 22. Which value to the nearest tenth is not a solution of p of x equals q of x if p of x equals that and q of x equals that? So here's how you do this question. Just because it says to the nearest tenth, folks, for them to say that, what should be blaring in your head is, I cannot solve this algebraically. I have to use my calculator. You have to use a graph page because you cannot solve for those complex decimals. So I'm going to go to my graph page. I'm actually just going to graph all these. X to the third plus 3x squared minus 3x minus 1. Enter. And you get 3x plus 8. Okay, so we get this. Now, I'm going to do menu. I'm going to fit this. Here we go, fit. That is too big. Give me 1 second. I'm going to zoom in just a little bit. Maybe a lot of bit. Okay, this is way... Hold on 1 second, folks. Let me zoom this in. This is ridiculous. Oh, you know what? Hold on a second. 10, negative 20, negative 10, and 20. All right, that's better. So I could see it. All I did is I just changed my window settings. So what I'm gonna do, and look here, people. It says which value to the nearest tenth is not a solution when these two functions are equal. Well, clearly there's gonna be one of these are the answer, because there's only 3 points of intersection on this graph. So what I'm gonna do is I'm gonna do menu. I'm gonna do analyze graph and do intersection. Click before and after the point of intersection. So there's one intersection point. Menu, analyze, graph, intersection. Do it again. Move that point over there. And do it one more time. Okay, people. So The problem is the answers. Oh, no, that's good. Okay. Again, I'm going to take a picture. Oops. I'm going to take a picture of this. Picture. Okay. Here we go. Let's go ahead and analyze. What am I doing? Okay. So we have our intersection points. Our intersection points are negative 3.94, negative 1.11, and 2.05. When you round these, you get negative 3.9, negative 1.1, and 2.1. These are the intersection points, so the only one that does not work is 4.7. Pretty simple question. Just graph it and get your intersection points. That's it. Moving on to number 23. The population of Jamesburg for the years 2010 to 2013, respectively, was reported as follows. How can this sequence be recursively modeled? That is the key here, folks. Recursively modeled. What does that mean? Well, recursively modeled means that you're given the first term. So if you're given the first term, it's recursion. Look at these two answer choices. Choices 1 and 2. That is not recursion. That is explicit. You're not given the first term. It has to specifically say what the first term is. Choices 3 and 4 show recursion because you're given the first term. Now your goal is to just figure out which one will give you these answers. Okay. You got to take it slow with this. Take a look at choice 3. You have this number and you have this wacko number here, and you're trying to find the answers. So we're given for this one, j of 1 equals 250,000. Let's now find j of 2. J of 2 is 1.00375 j sub 2 minus 1. Well, j sub 2 minus 1 is the same thing as j sub 1, and we know what j sub 1 is. It's this one, 250,000. So I'm just going to multiply this number times the 250,000. When you multiply those two numbers, you get this. You get 250, 937.5. So we get 250, 937.5. Not exactly that, but we're close. We're just 0.5 off. Now, let's say you went to choice 4. Okay? Say you went to choice 4. And you did this. Your j sub 2 term would actually be 250,937. And most of you would probably go for choice 4, but I'm telling you right now, it's not the answer. It's not the answer. Because if you go to j of 3, it is not going to be this. It's actually going to be off, if I'm not mistaken, you'll be off by 4 people. This is the better answer. Even though everything's rounded, because every answer you get, it's going to be off by 0.5. So just because I'm lazy, j of 3 is actually 251,878.5. And then for the j sub 4 term, it's 252,822.5. Even though that you're off by 0.5, it's still a reasonable answer. Your answer is choice 3 for that question. Choice 4 would eventually not work anymore. And the last question, number 24. Okay, when I saw this question when it came out, I had to read this like 5 to 10 times. I didn't, it was very hard for me to read this. So 24 says, let me try to explain it to you. The voltage used by most households can be modeled by a sine function. The maximum voltage is 120 volts, and there are 60 cycles every second. Which equation best represents the value of the voltage as it flows through the electric wires, where T is the time in seconds? Okay, a couple things that you need to know to get this question right. Your period formula is 2 pi over B, okay? Where B is your frequency. The period, let me tell you what period means. Period is the amount where the sine, in this case the sine curve, completes one cycle. Okay? So, if there are 60 cycles every second, the period is actually 1 over 60. Now, where did I get 1 over 60 from? Well, the 1 represents the cycle, and the 60 represents the seconds. So that is your period, people. Now you just set it equal to 2 pi over b, and what you're doing is you're finding the frequency. Because here's the thing. They give you the amplitude, and the amplitudes are all the same. It all comes down to that number inside. Is it 160, 60 pi, or 120 pi? Well, let's go and solve for b. Cross multiply. So we get b is equal to 60 times 2 pi is 120 pi. That's your value of b. Your answer is choice 4. Now, let me just explain that one more time, because I guarantee most of you got lost right here by the period. That's personally where I got lost. And then after that, it's just easy math. The period of a sine or cosine function is defined as the amount where that curve completes one cycle. Just a little cycle. And there are 60 cycles every second. Every single second, there are 60 cycles. That's a lot of freaking cycles. That's why you get electrocuted. So what I'm saying here is in one cycle, in one cycle, there are 60 seconds. Okay? It's saying here that there are 60 cycles every second. What I'm doing is I don't want to say I'm taking the reciprocal, but for one specific cycle, there are 60 seconds. That is your period. I hope that question made sense. I think it was a very wordy question, but that is how you do that problem. All right, I hope that this video helped you. Make sure that you hit that subscribe button down below, and consider becoming a patron on my Patreon page. And make sure that you visit my website at www.nysmathragersprep.com for more math content in Algebra 2. Both of those links, the Patreon and the website link, are in the description below. And again, make sure that you hit that subscribe button. Helps me out a little bit. And yeah, that's about it. And I hope to see you soon.